Good morning, students, for the chemistry lecture. And last time you have learned the kinetic theory of gases. And we begin today with the next unit, that is the chemical kinetics. And in this unit, you are going to learn what is the chemical kinetics, then what is the rate of reaction, what is the order of reaction, then what is the molecularity of reaction, what are the first order reactions, the kinetic equation of the first order reaction, then examples and second order reaction, and the factors which depends the uh, rate of reaction, or on which factors the rate of chemical reaction it depends. In detail, you are going to learn in this unit. So, here chemical kinetics, it is the branch of chemistry and it is mainly concerned with the study of rate of reaction or velocity of reaction. And in the chemistry laboratory, you are familiar with this apparatus. This is the conical flask, this is the round bottom flask, this is the measuring cylinder, or it is just similar to the beaker. Then this is again a round bottom flask with long neck, and in this diagram they have shown the graph of concentration versus time. Okay, such type of apparatus you are going to use in the chemical laboratory and in the study of chemical kinetics. Here in chemical kinetics, you are going to learn what is the rate of reaction, what is the order of reaction, what is the rate law equation, what is rate constant, what is half-life time, and the temperature dependence equation. Okay, and simply remember that the reactants get converted into product, or reactants are converted into product by a chemical reaction at what rate. Okay, that is studied in the chemical kinetics. Here, the chemical kinetics is the branch of chemistry that deals with the study of reaction rate. I repeat, chemical kinetics is the branch of chemistry that deals with the study of reaction rate. Chemical kinetics also involves the investigation of reaction. It involves the conditions of concentration, temperature, pressure, catalyst, and these conditions control the rate of a reaction. Again, in chemical kinetics, we understood the mechanism by means of which the reactants transferred into product. In short, the chemical kinetics, it is the branch of chemistry. It mainly deals with the study of a rate of reaction or velocity of reaction and the different conditions which affects the rate of reaction and the mechanism by means of which the reactants they get converted into product. It is deeply studied in the chemical kinetics. Then you are very well familiar with the chemical reactions that are occurs in our daily life as well as in the nature. And the chemical reactions are of two types. Here some chemical reactions are slow reactions and some chemical reactions are very fast reactions. And the fast reaction, suppose the neutralization of acid with the base. That means if we add HCl solution into NaOH, the neutralization, that means the formation of salt and water takes place, and this reaction is a very fast. It takes place within fractions of seconds. Then the precipitation of AgCl, when we add HCl solution to the AgNO3, there is a formation of AgCl, that is the precipitation of AgCl, and again that reaction is very fast. Okay, then there are slow reactions. For example, the reaction between H2O2 with the help of catalyst, then the hydrolysis of methyl acetate. These reactions, they occurs with a very slow rate. Okay, and in this chapter, some reactions, they occurs with the moderate rate. Here the very fast reactions and very slow reactions. In between these two we have the reactions which are taking place at moderate reactions, and such reactions are well studied with the help of chemical kinetics. Okay, then here in chemical kinetics, the reactants, with the help of chemical reaction, they will get converted into product, or reactants are transferred by chemical reaction into the product. Okay, and what is the rate, what is the velocity of conversion of this reactant into product? Here suppose A, it is our reactant, then it will transfer into the product B. Okay, and as the chemical reaction proceeds, the concentration of this reactant A decreases. Okay, concentration of this reactant A decreases, and the concentration of this B, that is product, it increases. And if we plot the graph of concentration versus time, here the concentration of reactant A, it decreases along this curve. As time passes, the concentration, it decreases. Okay, concentration of reactant A, it decreases with time, and the concentration of the product B, it increases with time. Okay, and here we can define the rate of reaction as it is any instant at which the concentration of reactant changes or decreases with time, and the concentration of product, it increases with time. Suppose we consider C is the concentration. Okay, C is the concentration and T is the time. Then the dC by dt with negative sign, minus dC by dt, it is the rate of this reaction with respect to reactant. And if we consider the concentration C of the product, then the rate of this reaction, it is equal to dC by dt with positive sign here, because the concentration of the product B, it increases with time. In short, remember that the rate of reaction, it is given by minus dC by dt with respect to concentration of reactant, and plus dC by dt with respect to concentration of product. Then, an area of chemistry concerned with the speed at which a reaction occurs is called chemical kinetics. Okay, the area of chemistry concerned with the speed or velocity of the reaction, it is called as chemical kinetics. Then reaction rate. Here reaction rate is the change in concentration of reactants and products in a certain amount of time. Okay, the rate of reaction is the change in concentration of reactants and products in a certain amount of time, and the average rate of reaction, it is equal to the change in concentration of reactant or product divided by change in time, that is uh, equal to minus dc by dt, and dc it is the change in concentration, dt it is the change in time. Okay, minus sign with respect to concentration of reactant and plus sign it is with the concentration of product. Then the rate laws. Here for elementary or the reactions which takes place in a one step. Reactions which takes place in one step, then the order can be predicted from the molecularity. Here, suppose this is the reaction N2O5. It gives 2NO3 plus 1 half O2. And here, the rate of reaction, it depends on the concentration of one reactant. This is a one-step reaction or elementary reaction. So, the for elementary or one-step reactions, the reaction order can be predicted from the molecularity. And the molecularity of the reaction, it is the number of molecules taking part in the chemical reaction. And remember, it is always positive. Okay, the molecularity of the reaction, it is the number of molecules taking part in the chemical reaction, and it is always positive whole integer. Okay, then for multi-step reaction, the rate law must be determined experimentally. Suppose in this reaction we have hydrogen H2 plus Br2 as a reactant, and they gives two molecules of HBr. Here the molecularity of the reaction, it is 2 because we have two molecules involved in the reaction. Here, molecularity of the reaction, it is the number of molecules taking part in the chemical reaction. Depending on the number of molecules, suppose one molecule is involved, that reaction is called as unimolecular reaction. And if two molecules are involved in the chemical reaction, that reaction is called as bimolecular reaction. Or if three molecules are involved in the chemical reaction, that reaction is called as termolecular reaction. Okay. So, molecularity of the reaction, it is nothing but number of molecules involved in the chemical reaction. Depending on the number, we have unimolecular reaction, bimolecular reaction, termolecular reaction. And remember, molecularity, it is always positive value and it is always integer and not the fractional value. Then the rate of chemical reaction depends on the reactant concentrations, then the state of the reactant, whether the reactant is present in a solid state, liquid state or in a powder form. Then the next factor, that is the temperature. Here, temperature plays very important role in the rate of reaction. As temperature increases, always rate of reaction increases. Similar is the effect of concentration of reactant. As concentration increases, the rate of reaction also increases. And the next factor, that is the catalyst. Here, catalytic converters, catalytic converter in your car speeds the formation of less polluting products from your engine, and The catalyst, it is the substance. It do not take part in the chemical reaction, but it increases the rate of reaction. Okay. Catalyst, it is a chemical constituent. It does not take part in the chemical reaction, but it increases the rate of reaction. Such catalysts are called as positive catalysts. And some catalysts are there, they do not take part in the chemical reaction, but they decreases the rate of reaction, and such catalysts are called as negative catalysts. Here, kinetics predicts on how fast you reach equilibrium, not the extent to which the reaction proceeds. Again, the main factors which influence the reaction rate. Here, concentration of a reactant. The first factor here it is concentration of reactants. Rates usually increases as reactant concentration increases. Then the second factor, reaction temperature, and increase in temperature increases the rate of reaction. Then the presence of catalyst. As already I have told you, a catalyst is a substance which increases the rate of reaction without being consumed in the overall reaction. That means catalyst, it does not take part in the chemical reaction. Then the concentration of catalyst or its surface area are variable which influence the rate of reaction. Some catalysts are incredibly complex, and examples are enzymes. They act as a catalyst. Okay, that here they have shown the graph of concentration versus time, and in case of reactants, the concentration of reactant it decreases with time, and it is denoted by the minus dc by dt, that is the rate of reaction. Okay, minus dc by dt, it is the rate of reaction, and negative sign it is used to signify the concentration of a reactant it decreases with time, and the nature of the graph this is shown with this blue line, and the concentration of product it increases with time, it is shown by this brown line. Okay, and it is given by R, it is equal to dc by dt, where R it is the rate of the reaction and dc it is the change in concentration of product, dt it is the change in time. So we define the rate of reaction as the rate of reaction or velocity of reaction at any instant is defined as the rate at which concentration of reacting substance vary with time, and it is also defined as it is the quantity of a given substance which undergoes change in time. Okay, then we begin with the first order reaction. Here, order of the reaction, it is the number of molecules or atoms whose concentration alters, whose concentration changes during the chemical reaction, and that particular number it is the order of reaction. Okay, when the first order reaction, when the reaction rate depends on the first power of concentration of a single reactant, it is considered to be the order of a reaction, and examples are absorption, distribution, elimination. Then microbial death kinetics. Thus, the rate of reaction is directly proportional to the concentration of a reacting substance. Here, the rate of reaction is directly proportional to the concentration of a reacting substance and is expressed as this equation. Here, rate of concentration of a product increases and the concentration of reactant it decreases. So it is given by minus dx by dt. It is equal to k into cx. Here, suppose we consider x is our reactant and c is the concentration. So rate of reaction we can write as minus dcx by dt, and it is proportional to the concentration of x. So the proportionality constant here it is the k, and this k is called as specific rate of reaction or rate constant or velocity constant. Okay, here rate constant or velocity constant it is denoted by the proportionality constant k, and when the concentration of reactant is a unit, okay, unit, then rate of reaction it becomes equal to the specific rate of reaction. Okay, the derivation of the first order reaction we will see later on. So we revise the introductory part of the chemical kinetics. We revise here introductory part of the chemical kinetics. Here, chemical kinetics, it is the branch of chemistry that deals with the study of reaction rates and their mechanism. Okay, the branch of chemistry that deals with the study of reaction rates and their mechanism. Then rate of reaction, it is the change in concentration of reactant or product in unit time. Rate of reaction, it is the change in concentration of reactant or product in unit time. Then the unit of rate of reaction is the moles per liter per second. Okay, here in general reaction A plus B it gives C plus D. Then the rate of disappearance of A, the rate of disappearance of A, it is equal to minus the active mass of A by dt. This square bracket it is the concentration or active mass. Here the rate of disappearance of A it is equal to minus dA by dt, or where dA is a small change in concentration of A and dt is a small interval of time, and the rate of disappearance of B it is equal to minus d in bracket active mass of B upon dt, where dB is a small change in concentration of B and dt is a small interval of time. Then here the rate of appearance of C, that means A and B, they react to form C and D. Here we have A and B, these are the reactants, and C and D, these are the products. So the rate of disappearance of A, it is given by this equation. Rate of disappearance of B, it is given by this equation, minus dA by dt, and here minus dB by dt, where dA, that is D in a bracket, in square bracket A, it is the concentration of A or active mass of A. Okay, then the rate of appearance, that means products are formed. So the rate of appearance of C, it is equal to D in bracket concentration of C with positive sign divided by dt, and the rate of disappearance of D, it is equal to plus D in square bracket D upon dt. This dC by dt and d by dt, this is the concentration of product and it increases with time, so it is given by positive sign. Then where D in bracket D, that is the small change in concentration of D, and dt is the small interval of time. Therefore, we can write the rate of reaction, it is equal to minus dA by dt, it is equal to minus dB by dt, it is equal to plus dC by dt, it is equal to plus dd by dt. Then the rate law or rate equation, it is the expression which relates the rate of reaction with concentration of reactants. The constant of proportionality K is known as rate constant, and average rate, it is the rate of reaction measured over a long time interval, and average rate, it is equal to delta x by delta t, where delta x is the change in concentration and delta t is large interval of time, and instantaneous rate, that means the rate at any instant, it is a rate of reaction when the average rate is taken over a particular moment of time. Instantaneous rate, it is given by dx by dt, where dx is a small change in concentration and dt is the small interval of time. Remember, the rate at any instant, it is given by dx by dt. Okay. Here again you have studied the definitions of molecularity and order of the reaction. Here the molecularity of a reaction, it is the total number of atoms, ions or molecules of reactants involved in the reaction is termed as its molecularity, and it is always in a whole number and it is never more than 3. It cannot be 0. Remember, the molecularity of reaction, it is the total number of either atoms, either ions or molecules of the reactants involved in the reaction, and it is termed as its molecularity. It is always in a whole number and is never more than 3. It cannot be 0. Then you have learned the definition of order of reaction. The sum of exponents or power of the concentration of reactants in the rate law is termed as order of the reaction. It can be fraction or it can be 0. Then the rate constant, you know, When the concentration of reactant is unity, then the rate of reaction is known as the rate constant. It is also called as the specific reaction rate. The constant of proportionality K is known as rate constant. Then in detail, you will study the first order reaction for the next lecture. Thank you. If you have doubts, then you will ask me, and there will be a test tomorrow or day after tomorrow on the topic kinetic theory of gases. So prepare well. Thank you.